Today's learning objectives, we are going to learn the best practices to deliver quality systems, coordinated projects utilizing proven design workflows. We're going to discover multidisciplinary conflicts early in the design phase and learn tools and processes to enhance building code related design decisions. We're going to involve stakeholders and building system engineers and project managers in this BIM process. We're going to show you how to include and prioritize building code criteria to enable these stakeholders to make better decisions at the beginning and throughout the entire building construction. We're going to integrate building and site design, and I'm going to show you that also for you civil guys or girls. We're going to learn tools and processes to enhance visualization and the design and code compliant means of egress, areas of discharge, and access by emergency vehicles early on in the design process. Then we're going to show you how to design real-time collaboration between architects, engineers, and specialty consultants. Now, what you're looking here is the entire process from design, looking at it if you're looking at a clock around 11 o'clock for design. All the processes include design, delivery, and operation of a building are all located here. What the building industry is trying to have us do and is working is for a more collaborative effort to have all of these as part of one whole design. In essence, one building, one design, one team. Let's talk about this team and how they can work in a collaborative effort. So first, let me cover some terminology. The terminology that you might hear is such things as cloud storage, team collaboration, and BIM authoring, and in conjunction with team collaboration. What are those? So if you hear someone asking about cloud storage and sharing, it's an alternate method to such things as FTP or Dropbox. They're usually password protected, sometimes not. They include file storage, versioning, and some level of permission control. Next, team collaboration. What's that? It's any file format that can be put on the cloud, and it helps teams work together more efficiently on a centralized platform. Team collaboration on the cloud usually includes things such as viewing, searching, and sharing this information with others to keep everyone in the loop, everyone informed and involved on the project. It also gives those people access to the project using the desktop, web, or mobile devices, and gives them the ability to interact with stakeholders, architects, engineers, pretty much everyone on the design team to review and mark up. That's team collaboration. Next is the combination of BIM authoring and team collaboration as a terminology. This is enabling the team collaboration from above and BIM authoring, which enables cloud work sharing and model authoring through particular software, which I'm not going to mention till the end. This eliminates IT hardware and software setup, and teams stay connected in real time using such tools as the communicator within such software, which I'm not going to say. Now let's talk about BIM. Is BIM really collaborative? So when we were looking at a BIM model a long time ago, like 14 months ago, right? The typical way that you might share your model in such software, blank software, would be a blank work sharing. Now, this type of scenario, you have your different computers and you share it to your server, and that's all within your local area network. Okay, very important to distinguish this. Then when you want to send information, how do you typically do this? You print it, you email it, you send PDFs, which usually ends up with some type of markups. Now, let's talk about the current collaboration tools that you're using. Email, document management, network drives, and basic cloud storage. These four are basically the ways in which we currently are using our tools at hand to share our information. Now let's talk about each one of these and why you should replace these, or at least consider it. Email. First of all, it's not centralized. For those of you ever trying to find an email, you know you can find it on your phone. You can find it on your computer or possibly a tablet, and it's hard to locate and track. Next is document management. It's static, incredibly complex to use, and also very difficult to find and track information, and incredibly expensive. Next is network drives. These are your servers. They're hard to share, and they're incredibly difficult to access outside of the office without IT. They're expensive to maintain and constantly have to be maintained. They're hard to organize, and finding the latest version of the file usually involves IT. Next, let's talk about basic cloud storage. Look, everyone on the call uses some type of cloud storage like Dropbox or Box or some of the other ones from Microsoft or Apple. But they're not built for the design process. They're not for the designers, the engineers and architects. Plus, they do not include any model viewers or data access, and they don't have any design review or markup capabilities. Now, in an enhanced workflow, a collaboration workflow with software that I'm not going to mention, can use project concentric design, live review, a 2D and 3D viewer, which is amazing, through the web. It understands data and workflows. It's built for teams and it allows you to do design markups. This is what we call the enhanced collaboration workflow, all available on any device, from your smartphone to your PC or Mac to a tablet. And it's agnostic, meaning it can work on anything as long as there's World Wide Web access. In addition to that, it can receive any file format. As you can see here on the screen, this is just a small sample of some of the applications that can be read. So if you're working with other people, engineers, that are using any of these software titles that you see in front of you, you don't have to have that software installed on your computer. You, through the cloud collaboration, enables you to read any of these and review and use them through the cloud. Now, let's talk about the building. We're all here to do what? To build buildings. And it usually involves designers, engineers, construction managers, owners, vendors, occupants. And during that design process, how do we work together? We work by using CAD tools, video conferencing, plans, drawings, designs, models, management. Oh my goodness. And then how do we meet? We meet in person. We send markups, we have more meetings, we have issues, we telephone, we have calls. This starts to get cluttered. What we want to do within cloud collaboration, moving towards the future, is group this into 3 different groups. Simply put, people, data, and tools. Cloud collaboration enables us to take each one of these 3 things and basically group those into those 3 organizations, those 3 groups, all centered around the building. Now, let's talk about Bim authoring and team collaboration. In a perfect environment where teams work together, we would work together on one project, a common model. In this case, it's all centralized. It's accessed. The data and team activity is all on one site. In other words, teams across the globe have access to this information, and projects can be accessed on mobile devices, on a computer, and it doesn't matter what type of computer. This is the future. It is the now. Now, how is this done? This is, in essence, at the root level, done through what's called cloud work sharing. Cloud work sharing, forget the R letter there, gives the ability for the user to basically take an application and be able to synchronize that information across through the cloud. Now, what's wonderful about this is it only requires the connection to the web. Then you have the ability to download your file into what's called a local cache file onto your computer, and then just those changes, what's called the delta changes, go back to the cloud. Then everyone has the ability to work in a work shared environment. Let's see what this looks like and how easy it is to do. We're going to show you, or I'm going to show you actually workflows from schematic design through construction documentation. I hope you all are ready for this because we're going to go over a lot of stuff. So here goes. Taking a look at the very first thing, let's take a look at schematic design with real-time collaboration. So over here, I have this short little video, and by the way, these videos are sped up just for time's sake. Over here, I'm going to start with schematic design. What I've done is through the cloud, I've typed in an address here in Miami, and I can basically start to sketch out a design idea with very, very simple tools. and it's agnostic. It doesn't matter what the object is. In this case, I can use regular push and pull features. I can take a look at it from any angle and get real-world scenarios. I can push, pull, and I don't have to worry about what type of wall it is or what the material is made up of. This is just schematic design. This is taking your paper napkin sketch to a whole new level. In just a moment, you'll see how I can start to define and further elements, as fenestrations within the model. In just a little bit, I'm going to then invite someone else to collaborate with me in just a moment. So over here, I've saved this drawing. I'm going to continue to do a couple more little iterations, some little canopies on this, and there. Now I'm going to save this. I'm saving this to the web, and I'm going to start a collaboration session. Over here, I have the ability to share this with people via an email address. I send them the link, and my buddy Mark here gets the invite. He logs on from his PC, Mac, or mobile device, and what we're seeing here is his efforts on marking this thing up. He's actually looking at creating shadows and looking at sun shadow studies in real time in the geographic location of where this is located. In addition to this, we can also take a look at, right from schematic design, the elements on the side of the buildings that give us different type of shading devices. It gives us thermal dynamics. And so this is basically schematic design at the next level. Cool, huh? Now, let's take it to the design development. This is the end user experience. In this case, the same model, a different model in this case, is now uploaded to the cloud. As the designer and everyone on the design team, we can explore materiality in real time. What we're looking at is my screen capture of looking at this design model and looking at how the materials work. If we wanted to look at a larger scale model, you can see something like this. Look how quick the regeneration is of all of the building elements. We're talking thousands and thousands of building elements from a software, all located on the web. This information can be shared to anyone and accessed even on your iPad. You can spin it around, and with the technology that it has, it basically allows us to take a look at a large model. Cool, huh? Next, let's take a look at the next phase, design development. In design development, let me show you how easy it is to access this model. For those of you using the software not shown here, we're going to go through and just open the file. We're going to go through A360, and over here, just open the file. Just like that, we've now opened up the file through the cloud. We're all working collaboratively on this thing, and I'm not dependent on the server. And it was just that easy. Next, let's talk about construction documents. The CD phase in synchronizing our project information. I'll show you how easy it is to basically go through and synchronize this information with the model. So don't blink, you might miss it. Here we go, synchronizing. I'm sending it back to the cloud and done. Now granted, it was a little bit sped up, but it really is just that fast and that easy. Next, let's talk about the social aspects. Now everyone has a smartphone. Everyone knows how to instant communicate through Skype, through Talk, through any type of messenger. Now we have that ability to do that in said software. You'll notice in this little preview, I'm now synchronized and talking with my team. All the team is synchronizing, and I'm able to see everyone and when they're synchronizing, from the architect to the structural engineer, and I can basically chat with them. All this information is now part of the design model. Really neat, huh? Next, I'm not going to go over this unless someone has questions at the very end, but this is called the Patrick-McClemy curve. This curve basically shows the difference between traditional workflows in black, and this item number 3, versus the Revit workflow, which is number 4, which puts more emphasis during the design, schematic, and design development phase, when there is a less cost of design changes early on through schematic design. This is a really, really important model to see that we're following. And basically this is the reason why BIM is so successful. Next, let's talk about site guys. Okay, so site and civil. Over here we have the ability not only to coordinate architectural information, we can also do vehicle tracking live. And although I don't have a demo of this, this gives us the ability to basically track and make very, very easy modifications for vehicle access through a site. And just by simply dragging, let's say like a polyline, you have the ability to make sure a semi or a small Prius might be able to go through this roundabout. Let's talk about how the building and site work together in multidisciplinary. In this case, we have the building information. We're going to look at an early on design phase on how to build the site specific to a build the model specifically on a site. Again, I'm going to use the Miami area. That's my hometown over here. So I'm going to go over here and type in the address. When I do that, you'll notice over here it starts to pull in information. I've located the site where my project is going to be. And in just a minute, you'll see how I'm going to go through here and create the model. What it's doing, it's actually importing in GIS model data information. The information is specific exactly to the coordinates geographically located in the world. The location is then sent to me via email, and you'll notice in just a minute where I'm going to zoom in here, and the information that we're looking at right from the beginning, without doing anything, includes three-dimensional information. Take a look at this spaghetti mess of 95. Now, I might have to go back and tweak some of the roadways that didn't get imported in properly, but this is one heck of a start for schematic design in understanding what the site implications are for my project. That is building site model with public GIS information. Now, let's talk about site design and means of egress. In this case, I'm going to take the same model and continue to develop it. In this case, I'm bringing in that GIS information, the model from before. I'm bringing it into yet another application. This gives me the ability over here to then start to take a look at the site information, and with tools, I can then build my site model. Build my architectural model on the site, given the parameters of the roadway systems in a very constricted area. Continuing on with the next part is then taking that and putting it all together in a visualization. And the thing is, I'm not having to use very complex software that's hard to learn. This is all web-based with very, very minimal tools. As you see on the top, there's probably like 6 tools over here. I can bring in my architectural schematic design model. I can take a look at sun shade devices and basically real-world scenario of information that's geographically located here in Miami, which is going to be different than, let's say, somewhere up north, right? So I have information here with heat and cooling areas within the site. So I can understand which facade needs to have some type of sunshade devices. I can also include such things as trees, or in this case a sidewalk, or some type of barrier. Okay. Again, this is all schematic design, but the idea that I'm trying to drive home is that this is in the context of the site. Real-time collaboration. Next, let's take a look at how we then layer some more information, in this case, vehicular traffic for emergency vehicles. Simply by just dragging a polyline, I have the ability to go through and place live information in this model. As you can see, all these are different parts of the building that are outside of the building, within the building, and they all are part of one large design because it's part of the context. We can include such things as trees, and as you can see, it's very, very easy to put in. Or I can say, you know what, over here's my retention pond. Just like that, I can now add a retention pond. This information now is accessible on the web to everyone, and it is super, super easy to do. I can then do walkthroughs and drive-throughs in this area. And this is all done within a matter of minutes. Let's see how we take this and then coordinate it with our civil engineer. taking the information as the architect. Let's say I've already laid out this retention pond area over here. What I can do is basically export this out to another application, one that, let's say, your civil engineer might use versus an architect. Okay, so as the designer, I've built everything that I need, but now I need to coordinate this with my civil guy or girl, and they can easily import that information accurately with GIS information into their application. Not naming the application. I'll let the video speak for itself in a moment. All the topography and information is right there with layers and all the information. It's absolutely amazing. And the wonderful thing is, as the architect, I started doing this design with just a sketch. And now my civil engineer, with their application that they're used to using, has all the information that I've created. Pretty neat, huh? Now let's talk about structural engineers. More discipline, because we want to include everyone, not just the architects. We want to include the engineers as well. So to take the engineers' information, we would go through and basically go through and involve their information as well. So in this case, we have a said software application. The structural engineer has designed their workflow and their model. And over here, what we're going to do is share that with another discipline. This is all about team, all about collaboration. And over here, we're going to export that into the other application that our civil engineer might use. Okay, we have the ability to share coordinates or not, and then just from one application as the structural engineer, we're going to deliver this to our structural engineer, our civil engineer. The civil engineer can then integrate our model into their design. So now they have the structural model as well as our site information, and it's geographically located. And then we can turn on layers and basically involve the whole thing. Next is the architect. Let's see how the architect coordinates with civil. Same process. It's really, really easy. In said application over here as the architect, I have my Revit model. You'll notice all the fenestrations and everything that I've built into this. I'm going to do the exact same process over here and send this to my civil guy or girl. And just like that, I've selected everything. I'm now going to go through the process of delivering that over to our civil engineer. And in just a few clicks, I'm going to say, okay, let's send it over here to engineers. I want to include and export everything over here from my source point. I'm going to include all my coordinates. Hit OK. And give it a moment. And in just a minute, it's going to be brought into our civil engineers application. They then are going to be able to load this application or load the information from application on the left into application on the right. The civil engineer now has the ability to then coordinate both structure and architectural elements, both into their designs. So everything is accurately placed. As the civil engineer, they don't necessarily need to know the nuances of everything within the architectural model, but the building envelope is displayed accurately. As you see here, we have the ability to change the properties and basically bring everything in. Next, let's take a look at how this all starts to come together within parking layouts. So over here, we have the ability to use parking layouts very simply put. We also have the ability to import site topo information back from the architect's model into civil and vice versa. So now the civil engineer has provided the information back to the architect. This is round trip going from the architectural model to the civil back into the architectural model, and just with simple tools I can trim out just the excess stuff that I don't want to see in said application from the architect, and I can start to look at my design. You'll notice over here I have information from the inside and the out of roadway systems, all contextual information that is generated from the very beginning. And I can also do realistic renderings. This is just a simple rendering from the schematic design level. I got to tell you, the collaboration between all the softwares is here and now. As MEP and structural engineers, you have the ability to use applications that we're not going to talk about yet that are all cloud-based. So as the engineer, as the MEP and structural, you have the ability to easily upload this into the cloud and do clash analysis. Those clashes, as you can see kind of a little bit down below, give you the ability to find where those clashes are, identified with little red dots, and that can be sent out to your consultants as an HTML file, easily making all of this coordination effort done early on in the design process. Let's take a look at further multidisciplinary information for MEP and structural. Over here we have BIM 360. Oops, that wasn't supposed to be there. Let me just turn this up where everyone can, no, I'll just say it right here. So this particular interface allows us to take models and upload them to the cloud using an application that you didn't see listed here. We have the ability to what's called glue different parts of the project up to the cloud. And in this little process over here, we can merge all the different files into one application. You have the ability to create project pages, and this right here gives us the ability to take a project and include different models and merge them together into different pages of information. In this case, we've combined HVAC or the entire model, or just looking at HVAC and structure, or just the structure alone. So over here we have the ability to access all of that information live. You'll notice in just a second we're going to come over here and take a look at one of these models, and it's loading it in through the web interface. In this case, we have the ability to look at it in 2D and in 3D. And in live time, I'm looking at a model that is probably 400 megs, and on the web it's just a few hundred K. Okay. Over here we have the ability to do some further investigation and take a look at this information on the web. Information at our fingertips allows us to comment, review, and mark up. Next, let's talk about life safety, fire protection. Over here, under life safety and fire protection, we have the ability to take a look at information for the site. In this case, using an application, we have the ability to take a look at how emergency vehicles will go around the site. In this case, we're actually seeing how a fire truck, fire engine, can actually go through the site, and if any of those turns are too small. So early on in the design process, we can do what's called vehicle tracking live within the project. And this is all within the application that a civil engineer might use. We can further take a look at this in 3D and see how that model has access around the site to give full access to emergency vehicles. Any modifications can be done early on, and then you could even get a perspective right from the emergency vehicle itself. So all of this information is at your fingertips. Next, let's talk about fire protection. One of the most important and critical things nowadays is fire protection, and there's 3 primary strategies that are used to save lives and mitigate damages when a fire occurs. There's containment, suppression, and detection. Let's talk about each one of these. Containment restricts the movement of smoke and toxic gases to help contain the smoke or fire in a room, in the room of origin. Suppression, such as sprinklers, help to extinguish the fires until the first responders arrive. And then detection. Smoke detection. Devices such as fire alarms that emit an audible or visual signal to alert the occupants when there's a fire. All 3 of these things are critical when it comes to fire protection. And you might ask, which is the most important here? Containment. containment is the most important of the three because it is the best strategy. It basically identifies areas. If you'll notice on using a cloud model up at the very top, we've investigated how smoke travels through a particular area, and we want to contain the smoke in one area. So fire stops are required for containment issues. They're required by the building codes and must be included in your design documents and specs. They're enforced by the authorities having jurisdiction in the area, and most field problems can be avoided proactively by including these fire stop systems early on in the design process. And in just a little bit I'll show you what that will look like. Over here we have a picture of a workman who's actually placed these fire stops in red, where you can basically see the tilt-up wall where it's going to be poured in place here is going to be poured, but these fire stops are already located because the information has already been coordinated using a BIM process. Fire stops can be basically identified in 7 steps. You need to identify and qualify the penetrations throughout your building, export these penetrations to a BIM validation tool, perform clash detection to make sure that those penetrations aren't clashing with something else early on in the design process, define UL systems and products, generate a bill of materials, generate a submittal for the life safety officials, and the last one is to populate this 3D model with the BIM components. Right here you'll see a picture of what those fire safety devices, those fire stops look like in a said application that an architect would use. So early on in the design process, you'll notice I don't even have partitions up or a shell. We've just identified the floor systems and where each one of these fire stops need to be located. What's wonderful about this is it's as easy as putting in a light fixture, like a emergency light fixture or a 2x2, or placing a door in this model. This gives us the ability to put in these fire stops and have them follow through the entire cycle of the building. Really, really neat stuff. And fire stop in BIM is the way to do things efficiently. Now, with that, we are now at the end of the AIA portion. Over here, we've talked about learning the best practices and how to deliver these systems into a coordinated project utilizing proven workflows. We've discovered how to do multidisciplinary conflicts early and earlier in the design phase. We've learned tools and processes to enhance building code related designs. We've involved everyone, the stakeholders, the engineers, the project managers, the architects, the designers, everyone early on to see how this can be included and brought together early on, utilizing building code information and life safety information for the whole building. We've integrated and showed you different ways to integrate the building and site, which I got to tell you folks is amazing and at your fingertips to use this information early on where your building and site are well integrated. Next, we've performed real-time collaboration between architects, engineers, and specialty consultants. And now, this is officially the end of the AIA Continuing Education webinar. But wait, there's a little bit more. Now, since we've finished the rest of the AIA, I'm now free to talk about what are those applications that we were talking about. For those of you who probably guessed it already, Revit, of course, is one of those. But the other ones that you were looking at were all cloud-based, are Format 360, Revit, InfraWorks 360, Civil 3D, Vehicle Tracking, and Navisworks. Those are the tools that's called the authoring tools that are at your fingertips to work locally on your own machines. The cloud collaboration efforts that you see and that are available to every Autodesk subscriber is cloud collaboration. Some of these are free, some of them are paid. We have A360 Drive, BIM 360 Team, Collaboration for Revit, and BIM 360 Glue. All of these are dependent on the applications above. So if we have something built in Revit or Format or InfraWorks or AutoCAD or Civil, Navisworks, all of that information can then be cloud collaborated. The desktop collaboration tools include Revit Server. FTP, Dropbox, and Navisworks. Now, I strongly suggest staying away from Dropbox, or especially if you're using Revit. The BIM collaboration tools, BIM 360 team, really are meant for our design applications. And that's it. Hopefully we have some questions. It's about 1:15. And let's see if we have any questions out there from our audience.
And hello, everyone. This is Mark Quincy again. So as Rick has finished up, please go to your questions pane and please put in any questions that you have so we can make sure we answer them. Rick, I see one here. Again, you talked about the collaboration for Revit. Does everyone on the team need to be part of collaboration for Revit?
Oh, great question. Okay, so for collaboration for Revit, basically imagine it as if you want everyone to play in the sandbox, you have to pay to play. In other words, if I am working on a project and I want to involve another team member, they have to have purchased collaboration for Revit. Once they have purchased a seat of collaboration for Revit, that basically gives them the pass, enabling them to basically work on my model. And the way that it works is their access to my model is all based on the server. So on A360 or BIM 360 team. So yes, the collaboration for Revit, if you are part of a design team, you have to pay for it if you want to be a design professional to access and work on that information. Now, if you are a owner or just want to do read-only or review, but not necessarily open it up in Revit, you can work on it. You have to be subscribed or given access to it, but then you're only read-only. So I hope that answers your question.